So chapter 5 continues on. Now that we've been introduced to rational expressions and we've practiced simplifying rational expressions, we're going to move on to the different operations. Like we did in fractions when we were reviewing that in this course, we did multiplying and dividing and then adding and subtracting. So we're going to multiply and divide rational expressions in this 5.2. When we went about these in the fractions, a lot of people were multiplying across the top, multiplying across the bottom, and then reducing. So you can do that with the rational expressions using the skills that we did in the 5.1 to reduce this. So you would have divided this by 12 or taken a common factor of 12 out and got a 1/6 as an answer. Oftentimes, the people who did this with the reach in and reduce kind of idea, so if this looks familiar to you, it might have been you getting to the answer. If that's you, that's totally fine too. The way that this question here parallels, I'm just going to erase all of my work into what we were doing, is that what I was saying is we're always going to factor and then reduce. And so in these ones, you could factor the 3 because it's a prime number, we're done. And we could factor the 8 out into 2 times 2 times 2. I'm pretty sure nobody thought of fractions this way, but just humor me for a minute because this is how it parallels to our rational expressions. So these are my numbers fully factored. We're going to fully factor our expressions. And so you could go across and reduce anything that is the same top and bottom. And in this way, this gives you a third way to get to that answer of 1/6. I'm not saying that it's necessary to do these 3 different ways. In my experience, even when we get into these rational expressions, people are most happy going across the top, going across the bottom, and then reducing. We will come into, when the things get more complicated, the value of factoring before you multiply across, because it puts it so that you can do this canceling, which is super intoxicating in this chapter 5, I think. So if we take a look at B, the most likely way to do it is the way I did it in this, where you multiply across the top and across the bottom and then reduce. We have those skills from 5.1. So we'd have 20 x cubed y squared across the top. Across the bottom, we'd have a 15 x squared y squared. So now I could reduce this either with my greatest common factoring idea or with exponent laws or with what exponents really mean. Regardless, not even going to show my steps on this one, you should get to a 4x over 3. If you were someone who reached in and reduced, you might have got to this answer as well. And so I think I was using red when I was reaching in and reducing. So you could reach in and reduce if you were of that mind. And whoops, it didn't work. How did it not work? Oh, because that's a 2. And that's another way we could get to the same answer. So my most interesting thing here, or thing I'm the most interested in, is can you get to these answers? And again, I try and teach it different ways, not to confuse you, but to find a way that resonates. And when I'm teaching these in videos, I have no feedback to know which way you like. So hopefully I'm not confusing you in this. I'm trying to communicate a way that makes sense to you. Okay, so once we move on from the monomials, which are confusing because you've learned them 4 different ways now, we could get into the more complicated ones. And again, with these 2 words, we're going to factor things and then we're going to reduce them. And so this is akin to that reaching in. And I find that when they get more complicated like this, it makes more sense to people to factor and then cross things out. So the first binomial here is being multiplied, or sorry, first rational expression here is being multiplied by the second rational expression. So we're going to factor everything and then look for things that are exactly the same top and bottom. So the top part of the first rational expression, nothing I can do. The bottom part of the first rational expression, nothing I can do. The top part of the second rational expression, I can see a 6 as a common factor, and factoring that out, I'd be left with an x minus 3. The bottom part, Nothing I can do with a 9x. But now I have everything factored, I can reduce anything that I can see. And I find that people are, again, this is the way I've found people most like to do it, is cross out the big obvious stuff and then maybe rewrite it. Maybe crossing out these X's is something you want to do, but I find that people like kind of collecting their thoughts for a minute. So rewriting it as 6x over 9x. And then usually then you can go to that next step, the last step. You're dividing the top by 3, the bottom by 3. You get a final answer of 2/3 for this one. And I think we've lost all powers of intuition. I don't think there's very many people that would look at the original question and say, oh yeah, that's 2/3. So we do need a bit of a strategy. They're loaded words in that there's only 2 of them for the instructions in here. You're going to factor and you're going to reduce. If you want to be someone who reaches in and reduces ahead, you sure can, right? And reduces that to 2 and that to a 3. That's another way to get to that same answer. But I find that this step kind of like, okay, what the heck is going on? I've crossed a whole bunch of stuff out. I got to see where I'm at. This is a really nice grounding middle step. So that's the way I'm going to show that in my work. So D, when I take a look at that, the idea is to factor everything and then hopefully cross a whole bunch of it out. So D, the top of my first rational expression, I have a 5 as a common factor. And factoring that out, I'd be left with an X plus 3. The bottom part, nothing I can do with an X. And we're going to multiply this by 2x squared, nothing I can do with that, over the denominator of my second rational expression has an X as a common factor. So factoring that out, I'd be left with an X plus 3. If you want to be super crossy outy here, you sure can. I'm just going to cross out the big obvious stuff so that you can see what the heck is going on. So on the top, we'd have a 10x squared, and the bottom, we'd have an x squared. So now the final step is to simplify this rational expression where we're at, and I would give my final answer of 10. Isn't that so simple? Such a nice, neat answer here. Again, I'm going to just show it one more time. If you wanted to be that reach in and reduce thing, you've got 2 x's on the top that you could cross those ones out, and that's how you could see 5 times 2, another way to get to that 10. So my work gets super crossy outy like that, and I find people have a hard time following it. And so I like showing my work with this intermediary step because it looks a little bit neater and it keeps me a little bit more organized. So the next 2 down here, if I work through those with this factor and then reduce, I've got the top of my first rational expression is a trinomial. Mercifully, it's a simple trinomial, so I can use my shortcut. I figure out the numbers for my number puzzle, and those are the numbers in my binomials. The bottom part of my first rational expression, there's nothing I can do with it as far as factoring goes. The second part, or the numerator of my second rational expression, nothing I can do. The denominator of my second rational expression, I could pull a 3 out of that binomial. Now I get to the fun part where I can cross the big stuff out. If you want to reach in and reduce a whole lot more, you can, or you can kind of slap it all together and then simplify it from there. So I have a 6x and an x plus 2 on the top, and on the bottom, I'd have a 9x squared. So simplifying this, if I see it as fractions, if I see it as exponent laws, regardless, I get a 2x plus 2 on the top, and on the bottom, I'd get a 3x. I'm dividing this by 3 and this by 3, and then I can see I've got 1x on the top and 2 on the bottom, so they'd cross out and it'd be left with a 1 down below. There's a lot of thinking that could go from this step into this one. And again, hopefully I've given you the space to be comfortable in your thought process and hopefully not confused you with the multiple ways you could think about this. Another one to give a shot, I'm going to talk this one through and then I'll put the answers, the last 2 up. So the top part of the first rational expression, so I'd have a 3 common to both of my terms, so I'd factor it out. The bottom, nothing I can do. top, nothing I can do. Bottom, difference of squares. Super fun part, my favorite part of chapter 5, crossing the big stuff out. Put it all together, or you could keep scribbling things out if you like that. I'd get a 6x on the top, a 6x squared, and an x plus 5 on the bottom. So the 6x and all but one of the x's are going to go away. So I'd have 1 over x times x plus 5 as my final answer here. Remember that 1 remains. This stuff is in the denominator, so it stays in the denominator. Last two, I'll put the answers up and then give you some time to work through them. Lots going on. F has a hint straight out the top here where you have something in the wrong order. And so you're going to have to practice that skill of factoring that -1 out. So your final answer for this one would be a negative. Showing my work on C and F down here, I'm going to difference of squares, the top part of my first rational expression. Common factor, the denominator here. Nothing I can do with the numerator of my second rational expression. The denominator of my second rational expression is a simple trinomial. It's one of these wacky ones with the y stepping up in it as well. You can use the shortcut for this one. You may not have. At the top of your number puzzle, you would have a +1. And the only way you're going to get to a +1 is a 1 times 1. My B term is positive, so they're both positive. And so this one's a weird one, not only because it's x's and y's, but because it's the smallest numbers possible. And so what I would have is an x plus y and an x plus y. This one might be too fast in my explanation because it has these multiple variables. Depending on how many practice ones you did like this, you might not be comfortable using the shortcut. Remember, the long cut always does work. Okay, so then I get to this point of crossing things out, which I really, really like. On the top, I'd have a 10xy. On the bottom, I'd have a 5 times x plus y. And here I can have that reduction. So I'd have a 1 and a 2. So my final answer is that 2xy over the x plus y. For f, I'm going to work through this one. I have nothing I can do on that numerator. I have a common factor of x in my denominator. So factoring that out, I'd have a common factor of 5 on my numerator here. I'm not going to get too worried about the order. And nothing I can do on the 8. This should stand out because it's almost the same as this one, but it's in the wrong order. So this is where sometimes some optional work out the side. So factoring that -1 out would give me an x minus 2. So I'm going to take the time to rewrite this just for clarity. So I'd have -5, just throw that one together, the x minus 2. Or you could just have that -1. Doesn't really matter where it goes. Now I have these two exactly the same, and I could have a -20 over 8x. If I were to divide the top and the bottom by 4, that's how I'm getting to my final answer of -5 over 2x, or negative of 5 over 2x. Doesn't matter if this is with the 5 or out in front, or heck, you could put it with the 2x. It would still be correct.